Solving polynomial equations. According to fundamental theorem of algebra, if p of x is a polynomial equation of degree n and with real coefficients, then it has at most n real roots. Let us have example. The given is x minus 2 times 2x plus 3 times x plus 1 equals 0. Our given polynomial equation is expressed in factored form. When the equation is expressed as linear factors, the zero product property will be applied to solve its solution. What are we going to do with our given is equate each factor to 0. Thus, x minus 2 is equal to 0, 2x plus 3 is equal to 0, and x plus 1 is equal to 0. And then we simply solve our value of x given each linear equation. For our x minus 2 equals 0, we need to add positive 2 both sides. So x becomes 2. For our 2x plus 3 equals 0, first, we need to add negative 3 both sides. So we have 2x equals negative 3. And then we eliminate our 2 besides x by multiplying 1/2, which is the reciprocal of 2, to the whole equation. So 2x times 1/2 is equal to x, and negative 3 times 1/2 is equal to negative 3 over 2. For our x plus 1 equals 0, we need to add both sides of equation by negative 1. So our x becomes negative 1. Given the equation x minus 2 times 2x plus 3 times x plus 1 equals 0, our roots, or the values of x of this given polynomial equation, are positive 2, negative 3 over 2, and negative 1. Let us have another example. The given is x times x minus 3 to the 4th power times x plus 6 squared equals 0. The given here is still in factored form. So we apply again the zero product property. So our x will be equal to 0. Our x minus 3 to the 4th power is equal to 0. And our x plus 6 squared is equal to 0. For our x minus 3 to the 4th power equals 0, this is the same as x minus 3 equals 0, x minus 3 equals 0, x minus 3 equals 0, and x minus 3 equals 0. So let us get one of these. So we have x minus 3 equals 0. Then we solve our linear equation. Our x is now equal to positive 3. But remember, we have 4 here, so we can note that our x is equal to 3 multiplicity 4, which means there are 4 values of x which are equal to 3. The same thing with x plus 6 squared equals 0. Our x plus 6 equals 0 can be simplified as x equals negative 6. And note that we have raised to 2 here, so we can have here multiplicity 2. Therefore, the roots or the zeros of the given polynomial equation expressed in factored form are 0, positive 3, with multiplicity 4, and negative 6, multiplicity 2. In solving polynomial equations, which are not expressed in factored forms, we use factor theorem, synthetic division, and the rational root theorem. In performing rational root theorem, we follow certain steps. Let us have example. The given equation is 2x cubed minus x squared minus 4x plus 3 equals 0. The first step is arrange the polynomial in descending order. In our given equation, it is already arranged in descending order because we have raised to 3, raised to 2, raised to 1, and our constant term. The next step is write down all the factors of the constant term. These are all the possible values of p. And then write down also the factors of the leading coefficient. These are all the possible values of q. So in our given equation, our p refers to the constant term. So our p here is 3. And the factors of 3 are positive negative 1, positive negative 3. Our q refers to the leading coefficient. So in this given equation, 2x cubed is our leading term and its leading coefficient is 2. So our q is equal to positive 2 and its factors are positive negative 1, positive negative 2. The next step is write down all the possible values of p over q. So let us get p over q. So we have positive negative 1 over positive negative 1 is equal to positive negative 1. Then positive negative 1 over positive negative 2 is equal to positive negative 1/2. Then we have positive negative 3 over positive negative 1 is equal to positive negative 3, and positive negative 3 over positive negative 2 is equal to positive negative 3 over 2. So these are now all the possible rational roots of the given polynomial equation. Given again all the possible rational roots of our given polynomial equation, which are positive negative 1, positive negative 1/2, positive negative 3, and positive negative 3 over 2, the last step is we use our synthetic division to find the rational roots of our given polynomial equation. So again, our given polynomial equation is 2x cubed minus x squared minus 4x plus 3. Let us get our numerical coefficient and place this in the first row. So we have 2, negative 1, negative 4, and positive 3. Among our given possible rational roots, let us use first positive 1. We bring down the first number 2, multiplied by 1 is 2, plus negative 1 is positive 1, times 1 is 1, plus negative 4 is negative 3, times 1 is negative 3, and the sum would be 0. Since the remainder here is 0, meaning our given factor is a factor of the given polynomial equation, which means also that our positive 1 is a rational root of the given polynomial equation. From our given entries on the third row, this will become our depressed equation 2x squared plus x minus 3 equals 0. The depressed equation is an equation which has degree less than that of the polynomial equation given. So from our given depressed equation, 2x squared plus x minus 3 equals 0, let us continue using our synthetic division to find the remaining rational roots. So let us get the numerical coefficients again. We have 2, 1, negative 3, and this time, let us use again positive 1. We bring down the first number 2, multiplied by 1 is 2, plus 1 is 3, multiplied by 1 is 3, plus negative 3 is equal to 0. Since the remainder again is 0, our positive 1 is a rational root of the given polynomial equation. And then let us just continue doing the synthetic division to find the next rational root. Let us use negative 3 over 2. We bring down the first number 2, and then we multiply 2 by negative 3 over 2. So 2 times negative 3 is negative 6, divided by 2 is equal to negative 3. And positive 3 plus negative 3 is equal to 0. Since the remainder again is equal to 0, that means negative 3 over 2 is the last rational root of the given polynomial equation. Therefore, the rational roots of the given equation are positive 1, multiplicity 2, and negative 3 over 2. Let us have another example. Let's say our quadratic equation is x to the fourth power minus 7x cubed plus 17x squared minus 17x plus 6 equals 0. Using the rational root theorem, let us get the factors of our p and q and our p over q. So our p again is our constant term, which is 6, and the factors of 6 are positive negative 1, positive negative 2, positive negative 3, and positive negative 6. For our q, our leading coefficient is 1, and the factors of 1 are positive negative 1. So taking our p over q, we have positive negative 1 over positive negative 1 will be equal to positive negative 1. The same thing with 2, 3, and 6. So we have positive negative 2, positive negative 3, and positive negative 6. These are all the possible rational roots of the given polynomial equation. And we will use again our synthetic division to find the rational roots of our quadratic equation. Given the possible rational roots and our polynomial equation, let us now use the synthetic division. So our numerical coefficients are 1, negative 7, positive 17, negative 17, and positive 6. And this time, let us use positive 1. Bring down the first number, which is 1, multiplied by 1 is equal to 1, plus negative 7 is equal to negative 6, times 1 is equal to negative 6, plus 17 is equal to 11, times 1 is equal to 11, plus negative 17 is equal to negative 6, and negative 6 times 1 is equal to negative 6, plus 6 is equal to 0. Since the remainder is 0, our 1 is one of the solutions or one of the roots of the given polynomial equation. Let us continue using our synthetic division. Let us use again positive 1. We bring down 1, then 1 times 1 is 1, plus negative 6 is negative 5, times 1 is negative 5, plus 11 is positive 6, times 1 is equal to positive 6, plus negative 6, that is equal to 0. So since the remainder again is equal to 0, our 1 is our root of the given polynomial equation. The last entries of our given synthetic division a while ago are 1, negative 5, and 6. From this, we can get our depressed equation x squared minus 5x plus 6 equals 0. Since our equation here is in degree of 2, or this one is a quadratic equation, we can find our roots or the values of x by using different methods. We can use factoring, quadratic formula, or completing the square. Using factoring, we find factors of our given terms of the polynomial equation. That would be, the factors of x squared are x and x. Factors of 6 that can be used here would be 3 and 2. And then we will decide for its sign. So we have both negative, because if we're going to check this using the FOIL method, x times x is equal to x squared, x times negative 2 is negative 2x, negative 3 times x is negative 3x, and then negative 2x plus negative 3x is equal to negative 5x, then negative 3 times negative 2 is equal to positive 6. And then we equate again our given to 0 since we have factored form. So x minus 3 equals 0, that is x equals 3. And our x minus 2 equals 0, that would be x equals 2. So the other two roots of the given quadratic equation are positive 3 and positive 2. Therefore, the roots of the given quadratic equation are positive 1 multiplicity 2, positive 3, and positive 2. From our given x squared minus 5x plus 6 equals 0, we can also use the quadratic formula. The quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So the first step in performing the quadratic formula is the equation must be equal to 0. So in this case, it is already in its standard form and equated to 0. The next step is identify the values of a, b, and c. So from our given quadratic equation, our a is equal to 1. Our b is equal to negative 5. And our c is equal to 6. The third step is substitute the values into the quadratic formula and then solve for x and simplify. So again, given the values of our a, b, and c and the quadratic formula, we simply substitute the values and then simplify the given. So we have x equals negative, our b is negative 5, plus or minus the square root of, our b again is negative 5, so we have negative 5 squared, minus 4 times our a, 1, times our c, 6, all over 2 times our a, 1. Then we simplify. Negative times negative 5 is positive 5, plus or minus the square root of negative 5 squared is equal to 25, and negative 4 times 1 times 6 is equal to negative 24, over 2 times 1 is equal to 2. Then we have 5 plus or minus the square root of 25 minus 24 is equal to 1 over 2. From our given 5 plus minus 1 over 2, let us get the values of x. So we have x equals 5 plus 1 over 2 and x equals 5 minus 1 over 2. So in the first one, we have 5 plus 1 is equal to 6 divided by 2, this is equal to 3. And 5 minus 1 is equal to 4 divided by 2 is equal to 2. Therefore, given the quadratic equation, the other two roots of the polynomial equation are positive 3 and positive 2, which are the same using the factoring method that we have used a while ago. Given the quadratic equation x squared minus 5x plus 6 equals 0, we can also find the other roots of the polynomial equation by using completing the square. the first step in completing the square is to check if the value of a is equal to 1. Our a refers to the leading coefficient. So in our given x squared as the leading term, its leading coefficient is equal to 1. That means our a is equal to 1. The second step is to rearrange the equation so that the constant is on the right side. So we have x squared minus 5x equals, our 6 must be placed on the other side, so it will become negative 6. The next step is complete the square on the left side by adding a square of the half of the middle term. And then we add this number to the other side of the equation. So in this case, our middle term is negative 5. And to get its half, you have negative 5 over 2, and then we get the square. That becomes negative 5 squared is equal to positive 25, and positive 2 squared is equal to positive 4. So we're going to add 25 over 4 to the both sides of the equation. Thus, we have x squared minus 5x plus 25 over 4 equals negative 6 plus 25 over 4. The next step is factor the given on the left side and simplify the given on the right side. So since our given here is a perfect square trinomial, we can get its factor by having x minus 5 over 2 squared. We have the square root of x squared, which is x. The square root of 25 is 5, and the square root of 4 is 2. And then we use the sign of the middle term, which is negative. And then we raise it to 2. That's why we have x minus 5 over 2 squared. And on the other side, negative 6 plus 25 over 4 will be equal to 1/4. The next step is take the square root of each side of the equation. So what are we going to do is to get the square root of the given. So we have x minus 5 over 2 equals square root of 1 as 1, and the square root of 4 is 2. But remember, we have positive and negative. So we have x minus 5 over 2 equals positive negative 1/2. The last step is solve for the value of x. So from our given x minus 5 over 2 equals positive negative 1/2, we add both sides by positive 5 over 2. So we have x equals 5 over 2 plus or minus 1/2. And then let us solve for x. So we have x equals 5 over 2 plus 1/2, and the other one is x equals 5 over 2 minus 1/2. Since we have here similar fractions, we only add the numerators and then we copy the denominator. Thus, 5 plus 1 is equal to 6, copy 2, so 6 over 2 is the same as positive 3. And for the other one, 5 minus 1 is 4, copy 2, and 4 over 2 is the same as positive 2. Therefore, the same with factoring and quadratic formula, using completing the square, we obtain the same values of x, which are positive 3 and positive 2. Therefore, the roots of the given quadratic equation are positive 1 multiplicity 2, positive 3, and positive 2.